a bank charging their iPhones. So what I think this tells us is that we're dependent on electricity. Our society is dependent on electricity. In order to convert salt water into fresh water, harvest agriculture, or power a pollution control device, we need energy. So the good thing about this, though, means that if we can solve the world's energy crisis, we can subsequently solve all of these other problems, such as the lack of fresh water, deficiency of fresh food, and pollution of the environment. So the problem at the moment is that all of our energy sources, whether petroleum, coal, natural gas, or nuclear power, are expensive, non-renewable, or damage the environment. The Hirsch report, published by the U.S. Department of Energy, calculated that after 2015, the rate of production of oil will reach a terminal decline. Sadly, reusable technology only accounts for 8% of our energy use. I believe that the unlimited energy supply provided by the sun will someday help solve the world's energy crisis. Although solar energy is potentially advantageous, the high cost per watt is currently inhibiting this technology from being widely used. This means that until the price of solar batteries is lower, we will never be able to use this technology in developing nations such as Colombia. So while I was thinking about this entire crisis, I happened to be working at a pharmacology lab at Weill Cornell Medical College run by Dr. Edelstein. So at this lab, I made some amazing and inspiring mentors and doctors who really supported me throughout this entire process. So at the lab, they were creating drugs that affect the production of ATP in the body. So in order to run, walk, or even give a TED talk, you need to break down ATP in the body. So ATP is the molecular form of energy. And ATP is created in the mitochondria, the power plant of a cell and an organelle. And in order for this entire process to work, we need an energy transferring protein called cytochrome C. So I was looking at this process, and I thought to myself, this is an amazing, efficient system. This system is not just in our bodies, but in the bodies of plants and other animals, and even singular organisms. So I thought, why can't I take elements of this process and apply them to create a new type of battery? Well, that's what I did. I created a new kind of solar battery that runs off of cytochrome C. But in order to make this battery work as efficiently as possible, I realized that I could take a drug the lab developed and add it to the battery in order to protect cytochrome C. So using cytochrome C, I was able to create this efficient and this inexpensive energy technology. So one day, I hope to see this technology line the roofs of buildings in Colombia. So when I was young, I heard this expression: anyone can look in a fashion boutique. Anyone can look for fashion in a boutique or history in a museum. However, the creative explorer looks for history in a hardware store and fashion in an airport. So in school, science is separated into subjects. We have biology over here, chemistry over here, physics over here. However, what I realized doing research is that science should not be looked at as a series of detached subjects, but rather a web of interconnected ideas and principles. So through my own experience, I found that passion and a willingness to take risks drive scientific discovery and innovation. And I was thankful enough to have these wonderful teachers at Dalton and these amazing mentors at the lab who supported me throughout this entire process. So I believe that without passion, we cannot create energy, and without energy, society will just not work. So I know here that every one of you today has your own passion. So I would like to invite you to take your passion to the next level. So I think you should live, explore, create, and build through your passions. Thank you.